Okay, so in the last video, we saw that when people are able to borrow or save as much as they would like at a constant interest rate, in other words, when people don't face any credit constraints, they're going to choose their human capital in order to maximize the value of the present discounted value of their lifetime earnings. That is, they're going to choose the level of human capital where the rate of return that they get on their marginal unit of human capital, their last hour spent studying, is equal to the rate of return they would have gotten had they instead worked and invested that money in savings, right? Invested that money at an interest rate of 1 plus R. And the reason for that is, regardless of what you want to do with the money, your goal is going to be, if you're freely able to transfer money from the future to the present or vice versa, your goal is going to be to have the biggest income possible. So let's think about how this changes when people are not able to transfer money from their present selves to their future selves. In other words, when people do face credit constraints. And again, to keep this fairly simple, let's think about the most extreme example when people are completely unable to borrow or save. So in this case, rather than having a budget, we'll have the same preferences that we had before, right? Our preferences are still going to be a function of our consumption in period 1 and our discounted consumption in period 2, where the discount rate is given by this delta. But now, we're going to have a budget constraint that doesn't include the possibility of borrowing or saving. So as a result, when we think about what our consumption is going to be in period 1, we're only going to be able to consume what we earn in period 1, right? So we'll say C1 is going to equal W1 times 1 minus H, right? Just our earnings in period 1. And if we wanted to be really careful, we'd make this less than or equal to, because we're allowed to consume less than we produce. It's just we would be wasting, and we wouldn't actually choose to do that. And likewise, C2 is just going to be given by our income in period 2, our earnings in period 2, which is going to be our wage in period 2, times 1, which is going to be just 2 times A H to the 1/2, based on the functional form that we chose, right? So period 1 consumption is given by period 1 income, period 2 consumption is given by period 2 income. And because we don't have any borrowing or saving here, there's no way to link these two budget constraints to create one large budget constraint, because it's not actually possible to trade off consumption in period 1 for consumption in period 2 through borrowing and saving. Instead, the only way that we can do that is through our choice of human capital. So instead, how we're going to think about this problem, how we're going to solve this problem, is we're going to say, once we've chosen how much human capital we're going to invest, right, once we've chosen H, we have effectively chosen both C1 and C2, right? We aren't really making 3 decisions here, we're really only making 1 decision here. So what we can do is, in our preferences, we can just rewrite our preferences with W1 times 1 minus H in for C1, and 2AH to the 1/2 in for C2. So we'll rewrite our preferences as U of H log of W1 times 1 minus H plus delta log of 2AH to the 1/2. And so to find our maximum utility, right, our optimal choice of H, what we're going to do is just choose the value that makes this as large as possible. In other words, rather than solving a constrained optimization problem like we're used to, where we have preferences and a budget constraint, this is going to be an unconstrained optimization problem. Really, we're constrained by the fact that H can't be less than 0 or greater than 1, right? You can't spend negative time studying or more than 100% of your time studying, but that's not going to end up coming into play here. So how are we going to do this? Well, just like before, right, we have this constant return, this constant cost of human capital in terms of period 1 consumption, and we have this declining benefit of human capital in terms of period 2 consumption. So what this is going to lead us to is that the very first unit of human capital is more valuable than the next and the next and the next. So if we take the derivative and set it equal to 0, that should show us when the costs of losing period 1 consumption equal the benefits of gaining period 2 consumption. Every unit before that is going to be worth investing in. Every unit after that is not going to be worth investing in. So what we can do is we can set du dh equals 0. Right? So let's think about what du dh is going to be. We're going to use the chain rule to figure this out, right? So this first piece here, if we take the derivative of the outside of the function, it'll be 1 over W1 times 1 minus H. And then the derivative of the inside of the function with respect to H is going to be negative W1, right? So negative W1 times 1 over W1 times 1 minus h, right? And then the second part here, we'll do the same thing. We'll take the chain rule. So the derivative of the outside of this function, delta log 2a h to the 1/2, is going to be delta over 2a h to the 1/2. And the derivative of the inside of this function is going to be a times h to the negative 1/2. And I want to spend a moment thinking about what this function is telling us before we finish the math problem here. So what this is, right, if we think about what we did when we took the derivative of the inside, multiplied it by the derivative of the outside. This piece here, this minus W1, is going to tell us the effect of a change in h on our income in period 1, or on our consumption in period 1, since those are equivalent. Right, so this piece here is the change in consumption in period 1 with respect to a change in h. Right? And this piece here is going to tell us the change in our utility, the change in our well-being, with respect to a change in consumption. Right? It's going to tell us the benefit to us of getting an extra unit of consumption in period 1. So this is going to be du dc1. And likewise, this piece here is going to have the same interpretation. Right? Add to it dc2 with respect to dh, right, this piece here. And then this piece here is going to be the change in our utility, right, our change in well-being with respect to a change in C2. du dc2. So what this is telling us, right, the meaning of this is going to be that we should invest in human capital up until the point that the change in utility, right, our change in well-being, as a result of losing consumption in period 1, which is going to be the value of that consumption times the change in that consumption, is equal to the benefit we're receiving from gaining consumption in period 2, right, which is in turn going to equal the value of that consumption times the change in that consumption when we change human capital. Okay, great. Okay, great. So let's solve this thing and think about what we get. And as you'll see, I just magically shifted our utility in terms of h and our marginal utility in terms of h up to the top of the whiteboard here. Okay, so obvious things to see here. W1 cancels out with W1. AH to the minus 1/2 times divided by AH to the 1/2. The A's are going to cancel, and I'll end up with 1 over h. So this is going to end up being minus 1 over 1 minus h, right, plus delta over 2h equals 0. I'll move this over to the other side. I'll cross multiply. And then I'll shift all the h's to one side and solve. Right, so I'll end up with human capital investment, an optimal human capital investment that is equal to delta over 2 plus delta. So what are we finding here? What we're finding is that given our Cobb-Douglas preferences and perfect credit constraints, right, total credit constraints, what we're going to end up getting is that our optimal choice of human capital just depends on our preferences, in particular the degree to which we weight the present compared to the future. And the way in which it matters is if we have a delta of 1, in other words, we care as much about adulthood as we do about childhood, we'll end up spending about 1/3 of our time in our youth investing in human capital and 2/3 of our time working. If we care less and less and less about adulthood relative to our youth, right, if we care nothing at all about adulthood, we would spend all of our time working in period 1 and wouldn't invest at all in human capital. So if we compare people who have high and low levels of human capital in a world of perfect credit constraints where no one has any income other than what they earn working, what we would conclude is the people who have high levels of human capital are the people who value the future more highly. The people who have low levels of human capital are people who value the future less highly. And Although this specific result is going to come out of these particular preferences, which remember wasn't true in the unconstrained model, this general result that our optimal level of human capital is going to depend on how much we care about the future is going to hold whenever we face credit constraints. And I'm just going to mention one more thing. If we think about what's the more realistic model, we're generally going to believe when we think about credit constraints that people are able to save, but they might have restrictions on how much they can borrow. In other words, what we might really think is that our human capital is going to be whatever's lower between this value and the value that we found in our unconstrained model. In other words, if we would like to save money, right? If we would like to get less human capital than this, if we're able to borrow and save, we would be able to do so. Okay. Okay, so a couple of things I want to point out about this, or I want to ask you about. Based on what we just did, let's think about who's going to benefit the most, or who's going to change their human capital investment the most, if we increase the availability of student loans. In other words, if we shift from a model that looks more like this to a model that looks more like what we worked out in the previous video. So remember, in the previous video, you get a higher level of human capital if you have a higher return on human capital, meaning a lower wage rate in your youth and a higher ability level, right? A higher ability to turn human capital into earnings. And you're going to get a lower level of human capital if you've got high wages in your youth and low wages later on. In this model, your human capital is going to depend on patience. So what we're generally going to expect is the lower income you are, right, the fewer resources you have to invest in human capital without having to take out student loans, the more student loans are going to increase your human capital, right? High ability people who have low resources are going to be more likely to use student loans and benefit from student loans than either people with lots of resources in their youth or people who don't have very high ability and therefore don't have a very high optimal human capital if they're investing until the rate of return equals the rate of return on physical capital. We'd also expect that student loans are going to be more helpful for people who are less patient or who care less about the future relative to the present. If you're high ability, but you really, really highly value the future, you might be more likely to spend your time in college studying hard and eating ramen noodles and living in a cardboard box in order to save money for the future, and therefore you might not take out student loans even if they were available. On the other hand, if you're very high ability, but you'd kind of like to drive a really nice car now, or you'd kind of like to go to parties now, or this sort of thing, student loans might do more to encourage you to go to college. The other thing I want to point out is if we think about the social returns to college, we really want people to invest in their human capital up until the marginal, the return on an investment in human capital is equal to the return on investment on human capital. What that's going to mean is essentially resources are allocated efficiently across society, right? As a society, we benefit just as much by increasing your education a little bit more as we would by building an extra piece of machinery for a factory. If we've got a model like this, how much education people are getting is more divorced from what the return on that human capital is. The last thing I wanted to mention is I wanted to think a little bit about what these deltas represent. A lot of times, including in Borjas, you'll see this talked about as measuring someone's patience. In other words, people who have low values of delta are these sort of, live for today, YOLO types who don't care about the future, aren't thinking about the future, are short-sighted. And the people with high values of delta are going to be patient, careful, forward-looking, thinking about their future, concerned about, always have an eye on the next thing that's going to happen. In other words, we think about this as effectively representing people's psychology. And that's going to be part of what determines these values of delta. But the other thing is, remember, what these deltas are really telling us is how valuable consumption is now versus how valuable consumption is later. And so these deltas are also going to capture things like what my financial responsibilities are as a young person compared to what my financial responsibilities are as an older person. If I'm someone who is financially responsible for siblings or children during my youth when I would be investing in human capital, I'm probably going to have a lower value of delta because that financial responsibility makes my consumption now more important to me relative to someone who doesn't have financial responsibilities for other people in their youth, or even who is being financially supported or is able to draw consumption other than from their own incomes as a youth. We might also think, to give a really depressing example, there's a paper by an economist named Bill Evans that shows that during the crack epidemic, there's a very large increase in the murder rate of young men in inner cities, particularly young African American men. And during that time, there's also a big increase in the high school dropout rate. And he makes the argument that this increase in the murder rate effectively lowers people's discount rates, because if you're living in this environment, you might find it less likely that you're going to survive to adulthood, and therefore you're going to be less likely, optimally, to make investments in adulthood. So the point here is just we shouldn't think about these deltas purely as capturing psychology. If we want to think about ways that we can change people's human capital investments, we might also want to think about ways that we can make their income in the future more valuable, or make their income in the present less valuable, right? By reducing financial burdens on young people, or by increasing people's hope for the future. And I'll just stand aside and stand still for a minute to make sure that the video quality resolves on the graph. Great. Okay, I'll see you in the next video.